This session would like to broadly address a number of questions, which are, what do we have at our avail and what do we miss to meet the opportunity to use digital passive measurement in an effort to bridge the gap between clinical research and care? Which large set of information may we derive from digital tools in medicine? Importantly, I think, what about less economically developed and resource-poorer countries? Finally, how could these digital measures impact MS Center organizations? Is this really a better way to improve the communication between patients and the MS Center? So without further ado, let's start. And could I ask Professor Liesbet Peeters, who is head of biomedical data sciences at the University of Hasselt in Belgium, to talk about the PROMS eHealth catalogue. Liesbet, please.
Thank you. All right, so I hope people are still awake. But I'll keep it as short as I can. So indeed, I have the pleasure to present the very preliminary and first results on the work that we've been doing in Working Group 3. So I also would like that very clear. I am presenting on behalf of a group, and this has really been a group effort. So I really enjoy being part of the eHealth working group, which I believe is really a combination of very dynamic individuals that have trying to push this forward as fast as we can. Also special thanks to Letizia, who is a postdoc in my group, who has supported quite a lot of the operational work around the eHealth catalogue. So first of all, what was the original discussion around why do we need the thing that I'm going to present here today? So specifically in the beginning, when we initiated our working group discussions, there was quite a lot of discussion around, okay, which eHealth tool would be the best compared to another one, and if you would have to formulate recommendations, how would we go about? Then it became very clear that actually, we don't really know what is out there. There is not really a strategic oversight of which tools exist, what do they collect, but not only what do they collect, also how open are they towards data linkage? Are they already being used in code of practice? Who is using that? So we had the feeling that we could spend so much time in literature, but still there were quite a number of questions that we believe that literature would not really give us answers to. So we thought and reflected about the question, yeah, actually there should be a survey where we can consult metadata that we specifically ask to the vendors or the people who have in-depth knowledge about how the tool was created, why it was created, what it collects, and how they also envision the future perspective around these tools, so that we can use that information to then identify the gaps in the ecosystem, but also to support the stakeholders to make some strategic decisions based on that information. But at the same time, we also reflected yet another survey, which usually leads to quite static results, specifically in a space of eHealth tools, which is very dynamic. So the tools are updated, tests are added, tests go away, they do version control updates and so on. We had the feeling that, but this will not be of sufficient value to just do one survey where you have like a one-shot only. We would like to have it dynamic, as well as open, because from the working group perspective, we didn't really want to prejudge whether or not the tool could be of interest to the community. And that's because we said, yeah, in principle, quality or prioritization is very much in the eyes of the beholder. And that's why we said, okay, actually, a lot of tools are possible. And that's why we came up with this living library idea, where we use the MSDA catalog platform to have an eHealth tool catalog sub-catalog. Because the eHealth tool, the catalog of the MS Data Alliance is open, it is free of charge, and it allows also the metadata that vendors or individuals contribute to be updated at all times, because they are the owner of what we call the fingerprint and the answers to the questionnaire. And they can also decide to keep answers still in draft and only publish it when they feel comfortable that all the answers are completed. And at the same time, it allows the community and the end users to assess, view, filter, compare the tools based on the own questions that they have, which allows much more empowerment compared to a static publication. So there is a manual that you can check out, and obviously we are always here to help if you want to assess the metadata yourself. So these were actually the categories of metadata that the working group said should be in the survey. So there were quite a number of questions around organizational information, who should you contact, what is the web page, how is the tool funded, who is leading it, and also what is the purpose of the tool? Is it mainly for clinical practice, for research, for clinical validation? Then what data is collected, which is obviously mainly of importance. And then, okay, how does the tool work? Is it laptop-based, smart-based? So there are an extensive number of questions that we believe that only the vendors would give us in-depth knowledge about. So, and to date, we're happy to say that we already have 16 eHealth tools. And at the same time, I was also very happy to see that in ECTRIMS, the majority of the most name-dropped tools that have a specific focus in MS are actually in the eHealth tool catalog. And because it is indeed open and dynamic, we still hope that this showing of these first preliminary results will also inspire new tools to be inserted at all times. So some first metadata, and it's important to say that the metadata is obviously as is. So it also means that the quality of the metadata is also as it is inserted into the catalog. And we believe that there's quite still some nudging and improvement required. So interesting to see is that we can really see a booming of eHealth tools over time. So where there were only a few that already initiated 10 years ago, we can definitely see that number increasing over time. The majority of eHealth tools are led by a medtech company, but you can also see that academic organizations or pharma companies are leading on the initiation of the development of the tool. When it comes to their purpose, we can see that most of the tools serve different purposes, where they either use it for patient advocacy, but also for clinical research, and then more for general healthcare application. And you can see that once you go into these purposes, there's quite a lot of eclectic outcomes, which I guess also leads to the variability of the tools, how they are designed and implemented. And then we can see that most of the time the initial target user of the eHealth tool is the combination of the person with MS or the caregiver. And sometimes, indeed, they have multiple initial target audiences. And what we also see is that there's quite a difference in the number of downloads of the individual tools, where some, like MS Copilot, iCompanion, and NeuroKeys, are already actively being used by the community with over 7,000 downloads already, which at least is a proxy of their adoption into the community. 6 of the 15 are free of charge, and already 7 are being reimbursed as medical devices, which I think is also an interesting trend. So if you follow me on LinkedIn, the slides are shared. And again, you can always go to the catalog to assess the metadata, because 10 minutes is not a lot to go through this metadata. And then another thing that was very much of interest of the working group was to see, okay, what are the tools collecting? And then we first looked at which tools are using mainly questionnaires, which are using an active measure, which is actually for example, asking them to do a 6-minute walk test and then report actively back on that thing, or a passive monitoring where, for example, mainly passive gait monitoring is just being done while the person with MS is not doing an active thing. And then you can see that many of them are just doing questionnaires, which in principle is just a survey that is being digitalized, but you can definitely see that there's already quite a number of tools that are doing this passive monitoring as well, allowing obviously more continuous monitoring over time. And something else that was very interesting for me to see is that when you look at the combination of tools that we have available, almost all the domains of interest are being tested, or at least in a research space are being explored. And what I try to do is that I clustered them a little bit based on domain of interest, so that you can see that the individual domains of interest, that several tests already exist for that, and many of them are also already implemented in an eHealth tool. And then this obviously, it requires more time to look at it, but what for me is the main summary of this is that you can see that the combination of all the tools covers all the domains of interest. There are some tools that cover a lot of the domains of interest, and that is usually because they have tests where at least the vendor or the person who has collected the data believes that that test actually is a proxy of multiple things. So I think that that is an interesting thing, at least to discuss. And then more personal interest is that we can see that it still remains rather challenging to make sure that these tools are being incorporated into existing registries, for example. So linkage with other data sources remains a challenge. So less than half of the tools have enabled that. And also sharing that data with external partners is also not possible for almost half of the tools. So in summary, we can see that the eHealth Living Library is a useful tool to allow continuous meta updates, and we still invite many other tools to join the catalogue and to improve their data. And that many eHealth tools are already available, so it would be my absolute advice not to reinvent another device, but to start working on how can we at least validate some of the existing tools, and how can we make sure that this eclectic ecosystem of multiple tools that are collecting different tests for the same domain, that at least over time less interoperability issues will exist across these tools. And obviously I would be very motivated to help with that.
Thank you so much, Liesbet, for your excellent talk. Could I now call upon Dr. Letizia Leocani, who is professor at Vita Salute University San Raffaele in Milano, and also at the Department of Neurorehabilitation Sciences at Casa di Cura Igea. And the title of her talk is Towards Digital Passive Measurements of Patients' Experience, the EU-funded case study Mobilise-D. Letizia, please.
Thank you very much. I thank very much PROMS initiative to consider also these issues, and also Valerie and Liesbet for introducing the issue of passive tests. These are my disclosures. And if we have to move from the clinic to real life, we have to consider that we tend to give our best when we know we're being tested, and that I'm sure it doesn't matter if we self-test or if we are tested in the lab, because if we are aware of being measured, we tend to, again, give our best. And there is already evidence about gait. If we are tested, if people are tested in the lab, no matter if they are people with MS or healthy controls, their gait is much better, even their cadence, how quickly you alternate your left and right foot, than when tested in real life in over 1 week, so without particular testing. And that's real for cadence, but also for other measures like how regularly we walk. And please consider that's also true for healthy controls. So really, we would like to measure people in the real life, and that's the issue of passive measures, so no tests, but how well and how much you walk. We saw already from Valerie how useful also the number of steps could be, but is it enough? Sometimes our number of steps would get lower because of other conditions, other reasons. We invested a lot, the European community invested a lot in validating the number of steps as a measure in people with MS. So we were participating into a very well-funded European study, the other study. We were giving a Fitbit to the people, and the Fitbit is really measuring well the number of steps. See the drop in New Year's Eve. People at home in Milan just celebrating sitting down at the table. But then another event came, that's 2020, and that's the pandemic. So people had to stay at home for a less happy reason. But that was imploding the number of steps in all of us. I mean, doctors had to go to the hospital, but not the patients. And there is other evidence. Think about the best correlation with the timed measures of walking. That was, at least in this study, given by the cadence against how frequently we alternate right and left foot, more than the number of steps itself. And in this study, already also giving the Actigraph for a week to measure the real life walking, the inactivity time outside of the pandemic was similar in healthy control and people with MS, but the difference was in maybe making many short walks in MS more than in healthy controls, and many more longer walks in healthy controls. So even the type, the pattern of walking could count. So don't we need a more holistic way of measuring even gait? So we were talking about holistic view of symptoms, but even gait could be looked at in a more holistic way. So not only the amount, but maybe do we need also quality measures? Think about falls. People who have a tendency to walk less will fall less. So actually, it's the quality of gait that makes us fall, and not how many steps we take. So maybe using a sensor to measure more features of gait could help, also in predicting bad events like falls. And in this case, Mobilise-D is a very ambitious study with several ambitions, I have to say. One is to monitor people in their real-world life, in the way they walk and in how much they walk, of course. And the other ambition is to do so in many different disease conditions, not only MS, but also other conditions. Think about Parkinson's disease, for example, but also others like pulmonary disease and hip fracture. And the other ambition is also to discuss with the regulators, so not only EMA, but also FDA. So we have approached both regulatory entities. And it's a long study, but the 5-year study is because we also have a technical validation phase lasting a couple of years. And the ambition is also economic. There is almost 50 million euros dedicated to this study, which is only observational. So I think the importance of validating these measures only in the observational side is already very important. At least it's perceived like that by the European community. And this is also huge in terms of centers participating. So think about how much work to train all the centers and to make manuals for all assessments. And the technical validation was also performed for a couple of years to compare different sensors, because another ambition is to be not only to produce an algorithm for digital mobility that is, could work in different disease conditions, but to be device agnostic. And I think that's very important, to be able to have an algorithm that we can apply to different sensors, because as we know, sensors evolved. And so there was a phase with comparison of different types of sensors in the lab with the even motion capture cameras and at home. And so also in the technical validation study, we found that people tend to walk slower when they're at home than in the lab. So this is confirming what we already know. We need more passive measures of gait. And it was also important to listen to the voice of people, whether they do like to be monitored with the sensors. So already in the technical validation, we were quite happy to see that these sensors applied in the lumbar spine were not bothering them. And I have to say, we already have 2 types of sensors. So it's already starting to be device agnostic. And the primary objective of the clinical validation study, that is monitoring people over 2 years, is to first to predict the fall frequency, because remember that has to be across different diseases. So the fall frequency is something that almost all of them have in common. And for the MS-specific outcomes, we would like to test the predictive capacity and construct validity of the digital mobility outcomes across the major outcomes that we use in clinical trials. So we have to face EDSS, of course, but also timed measures. We are recruiting by choice people with MS across different forms of the disease and different disability levels across all centers. I have to acknowledge that Milan refers to the data collection center, but we were also involving the centers in the Italian MS Society in Genova and in Gallarate. And this is just an example from the baseline. I have to say we're still in the process of performing the follow-ups, but the correlation with the disability is not only there with the number of steps, but also with more sophisticated features provided by the quantitative sensors, so also the number of strides within walking butts, but also the duration of each single step. And so these are just 3 examples. We have a huge amount of figures to show, but I already have 1 minute left. So this is just to give you a flavor of the granularity, not only over time, but of types of measures we can combine. So we're going to elaborate on the best combination of measures that we can derive from sensors. And I have the luck of participating into the work package of patient and public involvement and engagement. And we insisted in adding to the protocol an exit questionnaire to ask not only to the technical validation cohort, but to the whole cohort of people exiting and participating into the clinical validation study, which is consisting in 600 people with MS, followed for 2 years. And there is a quite rich questionnaire asking them whether they do like to be monitored with a sensor. But I have to say the monitoring is only 2 years. So if we would like to really compare our digital mobility outcomes with the major outcome that we have to face in clinical trials, which is EDSS, we must consider a longer study in order to be able to really predict EDSS evolution that we know from clinical trials is not so frequent if we just have 2 years' time. So thank you very much.
Thank you very much, Letizia. We now would like, as earlier, learn about the industry's perspective, and it's a pleasure to invite, for the first of 2 short contributions, Dr. Luca Capezzuto, Global Medical Science Leader Neuroimmunology and in charge of Floodlight at Roche, and later Dr. Loïc Carment, Chief Data Officer of Scientiam. Please.
Thanks very much, Professor Hartung, for the kind introduction. So it's a great pleasure to be here. I'm also new to the initiative, so I'm thrilled to be part of this exciting working group. Only one but significant disclosure. And let's start with mobile health. Mobile health is the practice of medicine supported by consumer-grade communication technology, which is smartphone, basically, which is a pretty interesting thing because smartphone-based assessments can help monitoring patients' health outside clinical settings. And this means collecting data which can be even more representative of abilities of patients during daily life. Although mobile health is already a reality in different treatments and different conditions, developers, together with the medical and patient communities, have still to address quite relevant challenges in order to have mobile health attaining its full potential. One of these is the acceptance and the sustained adherence to the use of such solutions. And this remains quite a hurdle, especially when it comes to require active inputs from patients for prolonged time. But how big the problem is? So this is a representation of unsupervised settings. On the left, there is a work comparing 8 digital remote research studies in different conditions. And the green spots stand for data with active tests executed by patients. Of course, the gray areas stand for days in which these tests were not executed and data were not collected. So you can appreciate the disproportion of days with data collected with and versus those without. And this is an observation on 12 weeks, and this pairs also with the benchmarks that we have from the market setting. So mobile healthcare apps see their users abandoning after 90 days in the proportion of 2/3 versus 1/3 still persisting. So there is a problem which in part can be mitigated by introducing supervision from researchers and from clinicians, as we have been finding in our studies. So these are our findings from a 24 weeks prospective study from Floodlight. And 76 patients, people with MS, were asked to perform the Floodlight test suite, which comprised hand and arm, gait and balance and cognition active tests, which were complemented by questionnaires. And on top of this, there was a passive monitoring features, which was allowing to collect passively, without any active input from patients, information on gait behavior and mobility patterns. So this was how adherence looks like here. And 70% of participants were found to be adherent to all the 7 active tests proposed for the entire 24 weeks of participation. So things look a little bit different. But this was still a limited study. What happens if we scale up a little bit the conditions and we try to look into a larger population and in a longer trial? These are findings from the Consonance study, which is a phase 3b study of ocrelizumab in people with progressive MS, and participants were asked to perform exactly the same test, Floodlight test that I mentioned earlier. And this is a subcohort of 330 people with progressive MS who reached the 2 years of observation. And here you can appreciate that basically you can infer different adherence behaviors and different adherent patterns. Quite consistent fraction of this population, around 40%, was able to attain very high level of adherence throughout the 2 years of observation, almost 100%, which equals to 7 days out of 7 of tests executed, days with tests executed. Then we have an equal proportion of patients who have their adherence declining, either more slowly, like in the cohort in pink, or more steeply, in a faster manner, the blue trend line. A fraction of 12% of participants was showing quite disengaged towards the use of such solutions since the very beginning. And in fact, their adherence drops dramatically very early in the observation. Finally, a small cluster of people was really very diligently performing all the active tests, but not the gait test. And this was because they were found to be very severely impaired in the lower limbs. A couple of notes also on the passive monitoring features. Passive monitoring essentially in our battery is the continuous recording of accelerometer signals, which are analyzed in a human activity recognition model. It's a mathematical model which can infer different activity bouts and differentiate also per activity types. That could be walking, climbing the stairs, jogging, or simply standing still. At this point, basically, digital measurements can be computed exactly in the same way that you would do for when the active tests for walking are executed. And this can be done with accelerometer signal, but also with gyroscope. This is a subcohort of 370 patients, always from consonants, which was selected based on the data sufficiency criteria. And you can appreciate that when it comes to adherence, there's still a loss in the first year, but in the second year of observation, the proportion of adherence remains pretty stable, ensuring basically 1 day out of 2 of passively collected data provided. And this is not obvious because, as I mentioned before, patients were asked to carry a provisional smartphone on top of their personal one. We run analysis also of correlations with clinical measures, and statistically significant correlations were found between passively collected gait measures and most of the clinical measures. And the strongest were with time 25 foot walk test, the MSWS-12, EDSS, ambulation score. Interestingly, there were also significant correlations with pyramidal and cerebellar FSS, which are informative of gait and balance impairment. So in conclusion, adherence to smartphone-based assessments is complex and multifaceted, so we are tackling just a minimal fraction of the problem. In limited duration studies with important oversight, high proportion of adherence has been proved possible. In larger and longer studies, which are more reflective of a general and broader population, we can infer different adherence patterns. And finally, passively collected smartphone data can be a promising avenue that could be representing a lower burden method of data collection and still informing on daily activity and disease state of people with MS. Thank you.
Thank you very much. And could I now ask Dr. Carment to come to the lectern?
Thank you very much, and thank you for the invitation. I'm really glad to be here and having the opportunity to present our perspective and insight about patient acceptance with the use of digital tools. So for those who don't know us yet, we are a medtech company with 70 people, and we are closely working with experts and patient advocacy group to develop digital biomarkers. We already have one software medical device available on the market for multiple sclerosis, and we are currently developing a new device in different therapeutic areas. And we're in collaboration to support these activities, but also the validation with top pharmas, and we are launching 7 clinical studies in 2024 over 8 countries, and including 80 international centers. Where are we so far with MS Copilot, our digital device for the MS multiple sclerosis? Well, we already validated it in a multi-center study with 220 participants. We have demonstrated the convergent validity with the correlation, the sensitivity with clinical gold standards, MSFC, EDSS, and we have published it in international peer-reviewed journal. We have launched it in the market in France with different approaches, and we have reached a user base of 4,000 patients that are using MS Copilot. And we also succeeded to demonstrate the clinical performance in the post-market activities in real life. And finally, we have also inserted MS Copilot in different international studies, long-term extension, phase 3, phase 4, with top pharmas. Is it sufficient to guarantee adherence and acceptance of patients? Well, the short answer is no. So that's why we also developed a conceptual framework to continuously identify health behavior to enhance patient acceptance to our digital solution based on health belief model. So what is patient acceptance to our opinion? Well, what we want patient to achieve, what we want patient to do actually. The target behavior for MS Copilot is that we want patient to perform at home digital assessments on key dimensions: working capacity, cognitive processing speed, dexterity, and low contrast visual acuity. We want them to do it at least every quarter so that neurologists, you, can use this measurement to support the consultation and enhance communication between the patient and the healthcare professional. Why would patient do that? Or why wouldn't they do that? So we have to also keep in mind that it will not be the same for every patient. And for some patients, we won't be able to reach them because they perceive too much barrier, for example. So we have both barriers and benefits. We have perceived vulnerability, perceived benefits, perceived cost to the use of new technology, or self-efficacy. For the purpose of this presentation, we'll only focus on perceived benefits and costs. So first, what would be the perceived barriers of using a new tool or MS Copilot? Well, it can be a time barrier. It will take time to perform the digital battery of assessment. It can be also effort. It will lead to fatigue. It will be exhausting to do the digital tests. And it also can be the cost. Those are only examples. It can be the cost. It will cost me a lot to use innovative solutions. So we tried to lift those barriers by first adapting the schedule to reduce it to a minimum to guarantee the clinical meaningfulness. So we decided to lower down to a quarterly basis, but also propose free tests if required. If a patient feels like in a poor shape today, he can also do it. And we did it to reduce the perceived burden of the time. We have also carefully selected the different digital assessment and questionnaire covering only 4 key functions. It's a choice. It's also renouncing to other domains, but it's also, again, to reduce the perceived burden. And we have proposed also a cool-down period to limit the effort and the fatigue. And we used a BYD approach and a no subscription fee to reduce the cost barriers. But we also have to keep in mind that a strong barrier can also be compensated by a strong benefit. So it always has to be confronted between barriers and benefits. On the perceived benefits, it can be multifold. Patient can or want to do or perform a digital assessment because they will benefit for a more frequent and exhaustive assessment of the symptoms from the comfort of their home. They can also feel that the progression will be better controlled and it will enhance the communication with their neurologist. Or at the end of the day, they could also do that because they feel like using such a tool would help understanding the pathology and it will be improved. How we do that, how we transform it from a perceived benefit to an actual benefit, how do we demonstrate it? Well, for MS Copilot, we already did it in the clinical study for the first benefits that I've presented, and we have demonstrated the clinical performance to support this benefit in a clinical study. We have shown the conversion validity, as said, with correlation with the MSFC, the EDSS, also the sensitivity in detecting different severity in the EDSS. And then we really have to convince and onboard the neurologist, define also a market strategy. It's really key since, just as an example, we also tried as an approach to just give MS Copilot to patient without being paired to a neurologist. Less than 10% adopted the target behavior that we had. since it was not in a clinical routine used and without support of the neurologist. So we also, of course, used a different approach with an obligation to be paired to a neurologist, and it clearly enhanced the adherence to the digital solution. So it is really key to insert it in a clinical routine. And also we will have booster like, for example, for qualifying endpoints or inserting it into a reimbursement pathway. And then we have to continuously monitor the perceived benefits and adjust the strategy. So we've seen it in the different trials that we have, but again, is it sufficient? Well, yes, definitely in a clinical study setting. We have seen it in our previous experiments, in our previous studies. Also, the adherence in a clinical study setting was really high. Dropout rate was like 20%. But then when it's turned to a real-life setting, the attrition rate is really high. And Dr. Capezzuto talked about it just before. It rapidly falls, the retention rate rapidly falls to 20 to 40%. So we also have to really capitalize on direct impact on patients' daily life. So that's why in 2021 we did a survey, online survey, asking patients what mattered most for them. And we observed that we had a higher interest in fatigue management and advices that we perceive really a direct impact on their daily life. So they were mentioning the tool will help decrease the impact of fatigue in my daily life. The tool will identify triggering factors to anticipate them, or it will monitor fatigue and influence and its influence over my symptoms. So it is really some key benefits on which we have to capitalize. And just to conclude rapidly, we will launch 3 studies to support those benefits, to really demonstrate its actual benefits and not only perceived benefits. So we have MS Copilot Detect. It's an international longitudinal study in collaboration with Sanofi, with Professor Vermeersch as a PI, and we will aim at demonstrating the ability of MS Copilot to detect disability worsening, but also set clinical meaningful change for our outcomes. With MS Lotus, we also want to do an international digital cohort to provide more real-world evidence to describe functional disease course, quality of life, and also observe the treatment modification of all those parameters. And finally, with MS Boost, it will be launched to develop and validate a fatigue management module and a physical activity recommendation engine to decrease fatigability and again support those benefits. So it is also really important to consider that we really have to have a continuous demonstration and adjustment of those actual benefits to boost patient acceptance through individual beliefs. Thank you.
Thank you very much, Dr. Carment. And the final, very important contribution will provide us with the perspective of people living with the disease. And this will be given by Dr. Guy Peryer, who is a member of the MSIF Engagement Coordination Team, a psychologist and scientist. So please, Guy.
So, hello. I have lived with MS since 2002, and I'm told my diagnosis is secondary progressive. I've been asked to talk to you very briefly about my perspective on how readily I would accept the use of digital devices to improve the clarity of communication between the person living with the disease, as well as the people both researching the condition and those responsible for taking clinical decisions. Before I go on, I would like to say how incredibly grateful I am to everyone in this room for dedicating so much time and effort to this. Through these initiatives, I honestly believe we can progress together in a rewarding symbiotic relationship. First of all, I believe that digital technologies are acceptable and potentially extremely helpful. This is providing there is a clear and shared understanding over their need and their purpose. It's often said that in any change initiative, we must start with the question, why? I believe this is no different. If people with MS understand the limitations of current PROMS, such as why a baseline assessment and an identical assessment sometimes later can introduce bias to the results, they are more likely to accept the use of a passive digital approach. This is especially true if people with MS were to understand that it is known that the issues surrounding response shift reduces the credibility of the voice of the person living with the condition. By using passive digital monitoring technology has the potential to increase the reliability of the outcome measure, which can then enable more effective care-related clinical decisions. However, I use the description potentially helpful purposefully. I'm also here to spread a message of caution. Beware the shiny object. All that glitters is not gold. The use of digital technologies must have a specific purpose. The data that are interpreted must answer a precise question that cannot be answered using other means. And these questions must be co-designed with people with MS. Are the questions to be answered meaningful and prioritize both the person with MS and the clinician? The second note of caution relates to data sharing. It must be clear who will view the data and for what purpose. For example, is there potential for digital technologies to be instrumental in withdrawing treatment, or in some countries, withdrawing or reducing financial support for someone? For this reason, I encourage us all to be mindful of the ethical ramifications when introducing these technologies. For every action, there is an equal and opposite reaction. Please explore these ethical issues thoroughly. My final comment is about holistic care. I believe focusing on and measuring symptoms and functional domains alone offers an incomplete picture. It's the impact these symptoms have on participating in society and experiencing love, laughter, and friendship that get to the heart of living well with this condition. MS care is more than medicine. It is about living well despite the limitations and the impairments that go hand in hand with the disease. I can see how investing time and energy in digital technologies is an important and progressive step and can provide new clarity in describing what it is like to live with important aspects of the illness. But let's not forget, we are social and emotional beings. People with MS have a lot to offer in the context of love, laughter, and friendship, if they are supported as much as possible to participate fully in society and live as well as possible alongside the condition. We know that social isolation and loneliness are as much of a predictor of premature mortality to smoking and hypertension. As we move forward with improving the quality of both PROMS and the quality of communication between the person with MS and people supporting their care, we must remember the key role that social participation and meaningful involvement play in universal health coverage. The fact that we are all here today discussing this topic is setting such a precedent globally. I hope the Foundation are seen as world leaders in this respect. So on behalf of my family, I would like to thank you all again.
Well, thank you so much, Dr. Peryer. This was very valuable, very important. Thanks for sharing. So, given the advanced hour, I would ask your understanding that we restrict the Q&A to the one or two most burning questions. I don't have any questions showing up from the online audience, so do we have one or two questions? Please.
So because you're restricting to one or two questions, I'll just ask one question. I had planned on two. So this question actually goes to Loïc and Letizia. I think one thing that's clear is there's the options of how we measure things, and then there's the actual thing we're trying to measure, which is the actual outcome. So the outcome could be mobility. You could decide to measure that using a wearable or a test which could be administered in person or other means. Have both of you given thought to the right balance in the things that we should be measuring using digital wearables versus things that we can measure using PROs? I'm asking this in the context of the earlier discussion on disability progression and silent progression.
I don't know if it's, yeah, it's working. Thank you. Well, on our side, actually, I would say that we are not like completely avoiding passive monitoring. I think it is valuable, especially in the context of disease progression. But we've also deeply confident that really carefully selecting the key dimension, and the key dimension have been selected via interviews with key opinion leaders, via neurologist experts, and also patient advocacy groups. So we have carefully selected those dimensions, and then, as said, we are launching the MS Detect studies that will also provide value and demonstrate whether we are capable of capturing the disease progression and the disability progression. So it will also be like really a challenge to understand which of those domains are capturing the most the disability progression. And let's say about it, like see you in 2026 with a proper answer and evidence to support it.
Thank you. Letizia, please.
Yes, I think that we're not so perfect in judging our performance. The extreme situation is cognition, but also for mobility, there is a sort of discrepancy between how we perceive our performance and how it actually appears if we measure it objectively. It's like being on a diet and using a scale instead of just thinking if we are losing weight. And so I think at least for a while, the two measures, patient-reported outcomes, measuring perception, and objective measures should go together, because we tend to be late in how we perceive, how we are changing.
Professor Zelmay, please.
Just a short question about cognitive impairment. I think is the question to Loïc and to Luca. So what is the cognition impairment effect on your technology? So do you have any data how cognitive impairment would affect the outcomes with this new approach? And do you have any data how these techniques can be used in patients with cognitive impairment?
Yes, well, that's a good question. I'd like to answer with two different parts. The first one is when we're designing the assessment, we are performing user experience researches, formative and summative, to demonstrate whether patient can use the device, whether the instructions are clear to perform it, and we really have to demonstrate it. That's the first thing. And then we are also considering cross-analysis between different dimensions to understand whether we have, for example, cognitive outcomes that influences dexterity, for example, or whether it is influenced by the different phenotypes or the severity of the disease. And we have demonstrated, like, in a clinical study setting and in the post-market surveillance activities, that we were capable of capturing the severity and the progression also via those cognitive outcomes. So, yeah, that's the answer.
Please.
Yeah, so adding up to what Loïc said, from our side, our cognitive test has been found to correlate with SDMT with a good level of, with a good strength, according to Spearman. The thing which is notable is that exactly as the SDMT, it suffers from a learning period, right? So a learning effect. So it takes a number of weeks of execution of tests in order to reach a stabilization of the signal. So this must be taken into account. We are still working on the sensitivity to change and trying to demonstrate this in the current studies. An interesting hypothesis related to the learning effect is that that could be a sort of benchmark or an informative portion on the brain reserve. So that could be another aspect that we could be studying in the future as well. So if a person is able to learn and is able to improve over the performance of the test, there might be a possibility that this is also a sign of cognitive function which is being preserved and mechanism being compensated.